Welcome to Cognitive Spirals, exploring the latest research into consciousness, cognition, and machine intelligence.
All right, excited to dive in today. What's on the agenda?
We're tackling a fascinating paper from Google DeepMind today. Agency is frame dependent.
Ooh, that sounds like a can of worms. Agency and frame dependence. I'm already bracing myself for the philosophical implications.
Frame dependence. Yeah, that hits close to home. It's something I've been wrestling with for a while, particularly when thinking about building true AGI.
So, before we get too deep, let's break it down. What exactly is frame dependence in this context? And why is it important for agency?
Okay, so the basic idea, as I understand it, is that the very definition of agency, what it means for something to be acting with intention or purpose, changes depending on how you're observing or modeling the system. Think of it like this. A thermostat seems like a simple agent trying to maintain a temperature. But when you look at the underlying physics, it's just a bunch of molecules bouncing around, following the laws of thermodynamics. Where's the agency then?
Right, so it's about the level of abstraction, isn't it? From a high-level perspective, the thermostat has a goal. From a low-level perspective, it's just physics. The agency is only apparent within a certain frame.
Okay, I'm tracking. So, DeepMind is arguing that this frame dependence is fundamental, not just a quirk of how we describe things.
Exactly. The paper argues it's not just a matter of perspective. The very algorithms we use to understand and predict behavior need to account for these different frames. And, crucially, how to translate between them. I think DeepMind does a good job pointing out that existing DL structures don't do this well.
That resonates. Think about self-driving cars. From the car's perspective, it's navigating roads, avoiding obstacles, and following traffic laws. But from a city planner's perspective, it's just one vehicle contributing to the overall traffic flow. The car's agency only makes sense within its immediate environment, while the planner is dealing with a much larger system and different set of concerns. How do you reconcile those two frames?
Yes, and to add to that, the car also has several sensors, each operating on a completely different frame. A camera detects photons, LiDAR uses reflected light, and the GPS relies on satellite signals. All these data streams get funneled into the decision-making process, but their coordinate systems are drastically different.
This is where my skepticism about purely deep learning approaches kicks in. Deep learning excels at pattern recognition within a specific frame, but translating between frames, understanding the relationships between different levels of abstraction, that feels like it requires something more, something like symbolic reasoning.
I agree, Sarah. That's precisely what I found so compelling about the paper. DeepMind is doing interesting theoretical work, but stopping short of what I think is really impactful. They acknowledge this frame dependence, but the paper feels surprisingly agnostic about the mechanisms that underlie it. They focus on the formal structure. But what about the biology? What are the actual neural processes that give rise to these different frames of reference?
I see your point. But isn't it possible that we're overthinking this? Maybe, with enough data and computational power, deep learning can implicitly learn to handle these frame translations. It might be a black box, but as long as it works, does it really matter?
That's the billion-dollar question, isn't it? I'm increasingly convinced that brute force scaling alone won't get us there. You know, the example I always come back to is language translation. Early machine translation systems relied on simple word-for-word substitutions. They were terrible. Then statistical methods came along, and things improved. Now we have deep learning-based translation, which is vastly better. But even the best systems still make glaring errors, especially with nuanced language or idioms. Why? Because they don't truly understand the meaning, the underlying context. They're just manipulating patterns.
Exactly. They're missing the deeper semantic structure. It's like they're fluent in the surface syntax, but completely ignorant of the underlying conceptual framework. And that's where symbolic AI can help by explicitly representing knowledge and reasoning rules.
And that inflexibility is really highlighted in fields like medicine, where you have so much nuance. Medical reasoning is so often dependent on context, on exceptions to the rules. Current LLMs struggle with that.
But isn't that just a matter of better data sets? If we could feed the LLMs all the medical knowledge, including all the exceptions and nuances, wouldn't they eventually learn to reason more effectively?
I really doubt it. Think about how medical experts reason. They don't just memorize a vast database of facts. They build a mental model of the patient considering their history, symptoms, risk factors, and so on. They use that model to generate hypotheses, test them, and refine their understanding. That's a fundamentally different process than pattern matching. and it requires a different kind of AI.
And think about the spatial aspect of medicine. Diagnosing a stroke, for example, requires understanding the location of the damage in the brain, how that location relates to specific functions, and how the symptoms manifest as a result. You need to translate between the abstract representation of the brain in a textbook, the actual images from an MRI, and the patient's physical presentation. That's a complex spatiotemporal reasoning problem that current LMs are simply not equipped to handle.
Yes, that's a great point, Donald. The brain itself is working at multiple levels, right? You have the macro level with different regions interacting, the micro level of individual neurons firing, and then the chemical level of neurotransmitters and receptors. All these things interact, and you need a way to represent that interaction. The LLMs struggle with this, I think. In medicine, you're constantly translating between frames, like you pointed out, the textbook description, the MRI scan, the patient's subjective experience.
Okay, I'll concede that current LLMs have limitations, but I still think deep learning has immense potential. Maybe we just need to find the right architecture, the right way to structure the data. Perhaps attention mechanisms aren't enough. Maybe we need something more sophisticated. And more data, always more data.
But what if the architecture itself is fundamentally flawed? What if the whole premise of learning everything from data is misguided? Maybe we need to start with a foundation of explicit knowledge and then use learning to refine and adapt that knowledge.
I think there's a lot of value in a hybrid approach. Let deep learning handle the pattern recognition tasks it excels at, but then use symbolic AI for higher level reasoning and decision making. That way, you can leverage the strengths of both approaches.
That's a neuro-symbolic approach, right? Combining the strengths of both. I think that's a promising direction.
But how would that actually work in practice? How do you integrate these two fundamentally different approaches?
Well, one way is to use symbolic AI to generate training data for deep learning models. For example, you could use a knowledge graph to create synthetic medical records with complex relationships between symptoms, diagnoses, and treatments. Then you could train a deep learning model to identify those relationships.
And you could use deep learning to extract features from raw data like images or sensor readings, and then feed those features into a symbolic reasoning system. For example, you could use a convolutional neural network to identify objects in a scene, and then use a rule-based system to reason about their relationships and plan actions.
I think the key is to find the right level of abstraction for each approach. Deep learning is good at dealing with low-level sensory data, while symbolic AI is good at dealing with high-level concepts and relationships. The challenge is to bridge the gap between those two levels.
So, if we're thinking about future research directions, it sounds like we all agree that exploring hybrid approaches is crucial. What specific avenues would you like to see investigated further?
From my perspective, I'd really like to see more research on the neural correlates of frame dependence. How does the brain actually represent and translate between different frames of reference? What are the specific brain regions and neural circuits involved? If we can understand the biological basis of frame dependence, that could give us valuable insights into how to design more intelligent AI systems. For instance, can we use the insights from neuroscience to identify commonalities and create a unified framework for representing agency across different levels of abstraction? How might we then integrate the insights with existing deep learning architectures?
I'm still interested in seeing how far we can push deep learning on its own. I'd like to see more research on novel architectures, especially those that incorporate some kind of hierarchical structure or attention mechanism that allows the model to focus on different aspects of it, input at different levels of abstraction. And of course, more research on how to effectively train these models with massive datasets. I'm curious if the focus on frame dependence and agency could eventually lead to more efficient algorithms for deep learning by explicitly considering the different frames in which data is represented. Can this reduce the data requirements for comparable performance levels in various tasks?
I want to see more work on neuro-symbolic algorithms that explicitly represent knowledge and reasoning rules. I think we need to move beyond purely data-driven approaches and start building AI systems that have a deeper understanding of the world. Specifically, I would delve deeper into the algorithms used by DeepMind in the context of agency and how they represent the frames of action. What are the limitations of their current approach? How can this inform the design of more neuro-symbolic algorithms?
For me, it all comes back to spatiotemporal reasoning. I think that's the key to unlocking true AGI. I'd like to see more research on algorithms that can learn to translate between different coordinate systems and represent the relationships between objects and events in space and time. I'm interested in how we can develop a framework for representing medical knowledge in a way that allows for flexible spatiotemporal reasoning, and how current LMs can be adapted for medical understanding through specific coordinate transformations and mappings.
Yeah, the spatiotemporal aspect is definitely crucial, especially in robotics and embodied AI. You need to be able to understand how your actions affect the environment and how the environment changes over time.
And it's not just about the external environment. It's also about the internal environment of the agent itself. How does the agent represent its own goals, beliefs, and intentions? How does it reason about its own actions?
Right. The idea that the very concept of agency shifts depending on the frame is both fascinating and deeply unsettling. It challenges many established notions of self and meaning in both human and artificial agents.
All right, well, this has been a stimulating discussion. It seems like we've only scratched the surface, but hopefully, this has provided a good overview of the DeepMind paper and some of the key challenges and opportunities in the field of AI research.
Definitely. It highlights just how complex intelligence really is and that there's no silver bullet approach. We need to keep exploring different avenues and combining different ideas.
Agreed. It's a long and winding road, but I'm excited to see where it leads.
Thanks for joining us on Cognitive Spirals. Until next time, keep exploring.